In this video, we're going to talk about similar solids. And this is exactly like what we talked about earlier in the year with similar triangles. Remember, similarity just means it'll be the same shape, but just a different size. And their corresponding size will be proportional. Okay, so similar solids have the same shape, but not the same size. Two solids are similar if the ratio of their corresponding linear measurements are equal. So here are the types of linear measurements that they're talking about. Will be like the length, the slant height, diameter, width, perimeter, circumference, height, and radius. Those are all linear measurements because it's nothing squared, cubed, or anything like that. Okay, so now we're going to determine whether the solids are similar. If yes, we're going to give the scale factor in simplest form. You're always going to reduce and always find the simplest form for your scale factor, and ratios always do that. And remember, scale factor is just a number that you're multiplying one figure by to obtain the size of the next figure. Okay, so let's look at number 1. So you could say, oh, well, yeah, they're similar. They look the same shape, different size. But let's see if their sides are proportional. How are their ratios? Okay, so let's look here. So 6 feet corresponds to right here 10 feet. Let's go ahead and put it in a fraction. So we have 6 over 10. Okay, next I see 6. So notice I'm starting with the first and the second. Keep it consistent. So the first one is 6. That corresponds on the other prism, which is 10. So it's 6 over 10. Making sure use the right color. And then the last length we have is 8. That height corresponds to the height right here, which is 12. So you always want in simplest form, so we're going to reduce it. Let's think of 6 over 10. How can we reduce it further? So 6 and 10, I know the greatest common factor that I could divide by will be 2. Divide the top and bottom by 2. So I'm going to get 3/5. Now sometimes you might have to reduce it further so you can think of a bigger number to divide them by. So just look, 3/5. Can I simplify further? No, that's it. Good. So this one is the same thing, right? 3/5. And now let's reduce 8 over 12. So I know they're both divisible by 4. So I'm going to get 2/3. I check. Can I reduce it further? I can't. So these two ratios are the same, but not this one. All 3 have to be equal in order for them to be similar. So just because 2 is, the third one isn't. So this is not similar. So the answer is no. So because it's no, we don't need to write our scale factor because there is none, because it's not similar. Example 2, we have these two cylinders. Let's see if they're similar with our math. So I have the diameter right here, 24 inches. So that's your linear measurements, by the way, we're dealing with. 24. Now let's look at the diameter of the cylinder. Oh, I don't have a diameter for my cylinder. This is my radius. I want to know the whole diameter. So the whole thing will be 20. 2 times your radius gives your diameter. So it's going to be 24 over the other diameter, which is 20. Has to be consistent. And let's look at the other ratio that we're going to form. We have the height. 30. The height here is 25. So we have 30 over 25. Now, looking at it, they don't look similar. So let's just go ahead and reduce them. These two are divisible by 4. So I will get 6 over 5. And for this ratio, I get divide both by 5. 6 over 5. So yes, because their sides are the same, their ratios, then these two are similar. So yes. And what's my scale factor? Well, from the first to the second, it was 6 over 5. So you're going to write it as a ratio, 6 to 5. Next, we're going to compare surface area and volume. If two solids are similar with a scale factor of A to B, so like just your numbers like we did, then their volume and surface area ratios are as follows. If you have your scale factor, if I square both of those numbers, I get my surface area. Because remember, with the surface area, your units are always squared. Okay? Now, if I go back to my scale factor, if I cube it, that gives me my volume, the ratio, because remember with volume, you always have to have your units cubed as your final answer. So for the following examples, these solids are very similar, so you don't have to go ahead and figure out if they are or not. Just go through it right away. So now here, we have these two prisms. I want to find the scale factor. Now because they're very similar, I don't have to do each side. So let's just find a scale factor. I'm going to just do the height. I see the height here is 6, the height here is 3. So I'm going to go ahead and do, okay, so it's 6 over 3. And let's reduce that. 6 divided by 3 is 2. But I need it as a scale factor, like 2 to what? So remember, if it's not in a fraction, it's always over 1. So that's my scale factor, 2 to 1. Meaning this prism is 2 times greater than the small one. So 3 times 2 gives me 6. Yep. 7 times 2 gives me 14. Yes. 5 times 2 gives me 10. Or you could say this prism is half of this one. Okay. So now we have our surface area. So surface area, remember, was just A to B. To get our scale factor. Now we're into the surface area. To find the surface area ratio, we need to square it. So all we're going to do is, okay, so I have 2 to 1. That's what we had all this time. If I square both, that is my surface area ratio. So that one's going to be 4 to 1. Now for the volume, you are not using the surface area to find the volume. Because if you look back, it's the A to B, the scale factor, and then you cube that to get your volume of the ratio. So I'm still having 2 to 1, but now to find the volume, I'm going to do to the third power. So 2 cubed means 2 times itself 3 times. So you're going to get 8, and 1 times 1 times 1, so it gives you 1. So these are the ratios. So you always need your scale factor. Then from there, you can find the surface area and the volume. So example 4. When given surface area volume, is a good note, always find the scale factor A to B first. Always, always. So we have 2 prisms here. So I don't have a scale factor. I have the surface area. But that's okay. You can still work with that. So let's first, whatever is given, let's find that ratio first. Okay, so we're going to put this one first. We have 960 over 375. That is my surface area right now. That's the ratio. Always reduce it. Always, always, always. So if I reduce that, if I divide both by 15, that's an ugly 15, but okay. Divide top and bottom by 15, I will get 64 over 25. So, and I check, can I reduce this further? Nothing else is going to be divided by, so I'm done. So that's not my scale factor, that's my surface area. So I write the surface area ratio first. So it's 64 to 25. That's my surface area. So I need to find the scale factor and volume. You always need to find the scale factor first to help you find the rest. Okay, so my scale factor, remember, scale factor was A to B. Surface area, the ratio was squared, and the volume ratio was cubed. Keep that in mind. So if I wanted the scale factor to the surface area, I had to square my numbers. But now I have the surface area, and I want to go the scale factor. So I'm going reverse now. I'm going this way. So we're doing the opposite operation. So the opposite of squaring will be the square root. So all I'm going to do is the square root of 64 and the square root of 25, both of them. Not just one, you have to do both. So the scale factor will now be the square root of 64 is 8 and the square root of 25 is 5. And you can always double check. If I took my scale factor and I squared both, do I get this answer? 8 squared, 64, yep. 5 squared, 25. Awesome. So the last thing I'm looking for is my volume ratio. Even if you're finding the volume, you always use the scale factor. Always use that one. So I'm going to cube 8 and 5. That's how I find my volume. I don't know what up with my 5s lately. They're not nice. Okay, so 8 cubed and 5 cubed. So that's going to give you 8 times 8 times 8, right? 3 times of it. So it's 512 to 125. Okay, so that is the volume of your ratio. Next, we're going to go ahead and do problem 5. Pyramid A and Pyramid B are similar. Pyramid A has a volume of 648 meters cubed, and Pyramid B has a volume of 1,029 meters cubed. What is the ratio of the surface area of Pyramid A to Pyramid B? Okay, so what we have is the volume. Now this is important. They told you it's from Pyramid A to Pyramid B. Because sometimes they might say, oh, Pyramid B to Pyramid A. So don't always think it's the first over the second. It's just whatever they want you to do it as. Okay, so Pyramid A, the volume was 648. So it's 648. And Pyramid B was 1,029. So this was my volume. I have that as in a fraction. I'm going to reduce it. That way I can find my ratio. So if we divide the top, the numerator and the denominator by 3, let's see. Yep, if we divide the numerator and denominator by 3, that's how we're going to simplify it. That'll give me 216. And the denominator is going to be 343. And then I check, can I reduce further? And I'm like, nope, that's pretty much it. Okay, now let's work what we need to find. We need to find the surface area. So right now we have, it's A cubed to B cubed. That's what I have right now. I have 216 to 343. Remember, it always has to be reduced, your ratios, okay? I want to find the surface area, but I don't just find the surface area right now. Remember, you always have to find the scale factor. That helps you move forward. So, my scale factor is A to B. So remember, if I went from A to B to A cubed, B cubed, that means I have to put each number to the third power. So something to the third power gave me 216, and the other number to the third power gave me 343. Now, instead of just figuring it out, like, okay, what number could that be? You're doing the opposite operation. So back here, this was squared. The opposite was square root. So for here, this was cubed. To remove that and figure out what could that number be, we're going to do the cube root of both. Cube root of 216. And I'm going to do the cube root on the other side. 343. So that's going to equal, if I do the cube root of 216, that's going to give me 6. And 343, the cube root will give me 7. So that's saying like 6 cubed gives me 216 and 7 cubed gives me 343. So you're working backwards. So right now that's my scale factor. But I want to find the surface area. So that means I have A squared, B squared. That's my surface area. So whatever my A and B was, I'm going to go ahead and just square it. So I have 6 to 7. So I square both. So that means it's going to be 36 to 49. So what is the ratio of the surface area? It's going to be 36 to 49. So you always need your scale factor to help you with that. And last but not least, we have, if the prisms below are similar, find the value of x. Now, you may be tempted to be like, okay, so it's 840 over 105 equals 20 over x. But stop right there, because right here, x and 20, these are your linear measurement. It's your length. Okay, it's just a measurement. It's your width in this case. So this right here is not the length of that. It says it's volume. So let's go ahead to to find the linear measurements, I need to help me find the scale factors. So before we even get into all that, let's go ahead and focus on the volume first. So my volume right now, it's 840 over 105. They're both divisible by 105 as the greatest number, so I can divide numerator and denominator by 105. So I get 8. It's just 8, your answer. But because we need it as a scale, as a ratio, I'm going to put it over 1. Remember, if there's no number in the denominator, you put it over 1. So that's my volume right now. The ratio of my volume, A cubed to B cubed, is 8 to 1. In order to find my missing side right here, x, I don't need the surface area. I just want to find what that side is. So you need your scale factor. So whenever you're looking for a linear measurement, like we said in the beginning, like all these, any linear measurements, you always need your scale factor. So it's very similar to what we just did before. I want the scale factor, which is A to B. So I'm from the cubed to no cubed. How do I remove that? You do the cube root again for both numbers. So the cube root of 8 and the cube root of 1. So one number times itself 3 times gives you 8. That's 2. The cube root of 8 is 2. And the cube root of 1 is 1. So this is my scale factor right here. Scale factor. It's 2 to 1. So now we're going to go ahead and set up our proportion. So my scale factor is 2 to 1. So we could write as a fraction. That's how we're going to use that. So we'll have 2 over 1. That's my scale factor. This is 2 times greater than the other one, okay? So this side is 20. And this side we don't know yet. But like I just said, this is 2 times greater than this prism right here. So if you could just think of that, 2 times greater. So 20 is 2 times greater than x. What could x be? If you can't figure that out, then you just go ahead and just continue doing the cross multiplying. So we have 2x equals 20. So divide both sides by 2. So x will equal to 10. And because it's a side, I'm just going to leave it as centimeters. That's the answer. So sometimes, if you could just see it right away, because you know the scale factor is 2 to 1, you know, okay, so that means 10, 2 times 10 gives me 20, so this one was 2 times greater. But sometimes your scale factor doesn't always work out like that. You can have like 3 to 5 or something like that. So just always prepare your proportion. So whatever you're given, find the scale factor. Once you find the scale factor, put it as a fraction and put the corresponding part that you need. This is the top, the first prism goes on top, and then the second prism went on the bottom. Okay, so that's how we do when we're trying to find like solids, similar solids, trying to find the scale factor that will help you with the surface area, and using that same scale factor then can help you with the volume as well as finding missing linear measurements.